Hello students, welcome to the next class of Science 1. So in the last class we have discussed about the effect of speed on velocity. Today we are going to start with a new topic that is called acceleration. As you can see in the slide, let us do an activity. Take a one long plastic tube and cut it lengthwise into two halves as shown in the diagram. So you are going to take a long pipe, you are going to cut it into two parts. Take one of the channel shaped piece. So out of two pieces we have got, we'll take one channel piece and we are going to keep it slanting. As you can see here, place one of its ends onto the ground and hold the other at the some height. So it should be slanting and it should be able to hold it in this particular format. Take a small ball and release it from upper end of the channel, and then do one thing, really take a ball and keep it at the upper end and release it down and see what happens to that particular ball. Observe the velocity of the ball as it rolls down along the channel. Observe the velocity is what? Change in speed per unit time, or you can say the displacement upon time. So you are going to see how the ball is going to come from the top position to the bottom position and the middle position. Is the velocity at all the points the same? I can agree to you what you want to say. Whether the velocity at all the point is going to be the same, the answer is no. The velocity might keeps on changing. At the starting point on the top, the velocity is 0. As it starts moving, the velocity keeps on increasing. As it reaches in the between position, the velocity increases, and when it reaches onto the ground, the velocity is maximum. So as the ball is rolling down, the velocity keeps on changing. So this is what we have understood from this activity. In the childhood days, you also must have played the slides, or you also have liked to slide down over, and when you slide down, you also see that your velocity keeps on changing. From the starting point, the velocity is less. As you come down, the velocity increases, and when you touch the ground, the velocity is maximum. The same example is shown here. There is increase in the velocity in the middle, and then it becomes a 0 towards the end. So this is also example of acceleration. Now, why are we stretching so much upon the terms and taking these examples, and we are trying to understand? Because till now we have understood the speed is change in distance upon time. Then we have understood velocity is change in displacement upon time. Now we are going to understand what is meant by acceleration. So acceleration basically means change in velocity upon time. I'll repeat, acceleration means change in velocity upon time. So as you see the picture here, the formula of acceleration is given. Acceleration is change in velocity upon time required. So to put it in a formula, if I start an object from a 0 velocity, the initial velocity is taken as u. When it reaches the particular point, after that the final velocity is called v, and let's say it takes time to reach that particular velocity is time t. So acceleration indicated by small a is nothing but final velocity minus initial velocity, that is a is equal to v minus u upon t. A is equal to v is final velocity minus initial velocity upon t. Let us take an example for this particular formula or acceleration. If the velocity of an object changes during a certain time period, then what is going to change? The acceleration is going to change. So if the velocity keeps on changing per unit time, then we say that the object is showing an accelerated motion, or the object is showing the acceleration, that is change in velocity per unit time. So as you can see in the diagram, the car which was at 0 position, once it starts from that particular position and moves to the another position, initial velocity was u, and then it achieves a final velocity which is v. So if I want to calculate the acceleration of the car, I should take the final velocity minus initial velocity upon the time taken to reach from one particular point to another particular point. I hope this should make it very clear. Now when we talk about this acceleration, there are two types of acceleration. We'll talk about something called as uniform acceleration. If the velocity keeps on changing per unit time is same, I'll repeat, if the velocity of the object which keeps on changing per unit time is change, then I will say that object is showing a uniform acceleration. That is, if the velocity changes by equal amount of time, let's say for every 30 minutes the velocity is changing maybe 50 kilometer per hour. So every 30 minutes if it is covering 50 kilometer per hour, that means velocity remains the same for every 30 minutes. That means it shows uniform acceleration. So the object is said to have called as uniform acceleration. Whereas if the velocity keeps on changing per unit time for every interval of time, then it is called as what? Non-uniform acceleration. So it's very clear. Now they are shown your example here. When an object is at rest in the beginning of its motion, they shown a car, there is shown a bike here which says that when an object is at rest in the beginning of its motion, what will be the velocity of this particular bike? Since it's having an initial velocity, it's a resting position, the initial velocity is going to be 0. I'll repeat. Since it is at the resting position, the initial velocity is going to be 0. Then we talk about the next example. If the if this bike starts moving and it reaches a particular distance, then what will be the final velocity of that particular bike? So they're asking here, when an object comes to a rest at the end of its motion, what will be its final velocity? When the object is coming and stopping after covering certain distance, then again the velocity is going to be 0 because it is coming to the rest. So initial velocity at rest was 0, final velocity at rest is also going to be 0. When we talk about acceleration, there are two types of acceleration. One is called positive acceleration and the other is called negative acceleration. I'll repeat, one is called positive and the other is called negative acceleration. Now what is meant by a positive acceleration? We'll take example for this. As you can see here, when the velocity of the object increases, the acceleration is positive. So whenever velocity increases, the acceleration is going to be positive. Then the second condition for taking as a positive acceleration is when in case of acceleration is in the direction of the velocity. Let's say velocity is also in one direction and acceleration is also in one direction, then also the acceleration is positive. And third condition we'll talk about, or we'll see that when the velocity of the object decreases, it is called negative acceleration. If velocity increases, it's positive acceleration. If velocity decreases, it's going to be a negative acceleration. For example, as the car comes down, the speed decreases down, it will be called as a negative acceleration. The term for negative acceleration is also called as deceleration. I'll repeat, term for negative acceleration is also called as deceleration, as you can see in the diagram. Its direction is opposite to the direction of the velocity, and when it will happen, when it will be a negative velocity, when the negative acceleration, when the direction of the object traveling is in the opposite direction of the velocity, then I will say it is showing a negative acceleration. And when the object is at rest, it's not changing, then obviously the acceleration is going to be 0. So in today's class we tried to understand acceleration, change in velocity per unit time. Formula is final velocity v minus initial velocity u upon t, and we try to understand there are two types of acceleration: positive acceleration, negative acceleration, and zero acceleration. I hope this will make the idea of acceleration very clear. I request you to go through the video very clearly, listen 2-3 times, and I'll send you the homework afterwards in the WhatsApp group. Till then, take care, stay safe, stay at home, study well, and till the time we meet next.